Hi everyone, my name is Abby and I am the College Outreach Coordinator at Biodiversity for Livable Climate. And we are very excited to welcome today Ed Huling, who is an organic farmer and is going to be speaking with us about regenerative agriculture and nutrient density. Ed started out with doing a deep dive into human nutrition in his career. He started at Brandeis University studying environmental science, and he published in Science magazine as the first undergraduate student to do that. Following graduation, he spent a year at the Department of Agriculture in the United States doing research, and he spent the last 20 years focused on producing nutrient-dense food and developing solutions for climate mitigation as an organic farmer. So thank you, Ed, for joining us. We're very excited to have you here and to learn what you have to say.
Well, I'm very happy to be here and happy that to have people that are interested in making a change from the industrial system of agriculture and all the destruction that's done to a better way of doing things.
Absolutely. My first question for you is, what is nutrient density and how does soil health impact nutrient density in food?
The way that I look at it is I look at it more relatively in terms of what the nutrients that soil had in it and the nutrients that food had in it back before agriculture degraded our soil so much. The research I did at the Department of Agriculture showed that food even 100 years ago had significantly more nutrition in it than it has now. Back 100 years ago, they were doing all kinds of soil and food nutrition analysis. So I had a good baseline to compare current foods to. The short story is that a lot of the essential minerals that we need for our nutrition, including magnesium and zinc and copper and manganese and boron, many different minerals that we need that are essential for us to be good, healthy, have been severely depleted in soil. So as you might expect, when you grow food in soil where the levels of these essential nutrients has declined so much, then they end up at low levels in the food. And over time, we can become nutrient deficient, and that contributes to disease. And, you know, we don't have optimal health when the food that we're eating does not have the nutrient density that it can have. So the work that I ended up doing as an organic farmer, when I finished my research at the Department of Agriculture and the folks there didn't, for whatever reason, want to get on board to change the way things were done, then I left and became an organic farmer. So it turns out that it's not so trivial putting the nutrients back into soil, because soil is more than just minerals. It's also organic matter. It's also thousands of species of microbes that all work symbiotically with plants and plant roots and minerals. So it turns out that it's a lot more complicated than I expected, or put it this way, it was more complicated to fix depleted soil than I thought it would be. But the good news is that once I was able to restore the minerals and organic matter and diverse microbiology, we not only got better nutrition food, we got better tasting food. And in addition to that, we got more food. So it turned out that whether we were growing in a greenhouse or out in the field, that the soils can be far more productive. It's not just that it's not producing good food, it's also producing not as much food as it did historically before agriculture began.
Thank you for sharing that. That's absolutely fascinating, especially the fact that the food that was grown actually tasted better in addition to being more nutrient dense. That's a really interesting thing, although it does make sense that, you know, there would be a better taste to it.
Yeah, I mean, when you think about it, you know, we evolved taste to be able to distinguish between foods that are more nutrient dense and less nutrient dense. And so I think taste evolved for that reason, but we didn't evolve. In other words, our taste didn't go away when food declined and soil declined in nutritional value. So food just doesn't taste that good anymore. But when you have food that really is grown in nutrient-rich soil, it just has a very rich, whether it's the tomatoes that we grew or microgreens or melons, they just have just an incredible flavor. People just are so excited to eat good food. It's just innate for us.
Yeah, I think that also to me brings up the topic of how human health and planetary health intersect. It's really fascinating that something that can be so good for humans nutritionally and also just in terms of enjoyment, having better taste, is also grown in a way that is fantastic for planetary health and for ecosystem health. So I think it's a really wonderful example of that intersection.
100%. We are part of nature. We can't live without nature working for us, and we can contribute to nature, or we can destroy the environment and the conditions that we need to survive and thrive.
Yeah, I think that brings or at least leads really well to the next question, which is that you're an organic farmer. So could you please describe the farming and forestry systems that you created using restorative practices?
Yeah, I spent most of the last 20 years growing vegetables, organic vegetables, selling at Whole Foods Market. But a few years ago, my daughter, actually, who had been reading about climate change, came to me and just really challenged me and said, "Dad, how come your generation messed up the planet so badly, and what's going to become of me and my kids in the future?" And I didn't have a good answer for her, but spent the last 7 or 8 years adapting what I had learned about restoring soil to solutions that through farming and forestry can help mitigate climate change. So I think that the two things that I've focused on most in terms of farming system, one is to change the way we produce meat in this country. Basically, we have like 125 million acres of corn and soybeans that's grown, all over the country, but significantly in the Midwest. And it's a farming system with herbicides, which is, poison to kill weeds, chemical fertilizers, other toxic pesticides that are sprayed on the corn and soybeans for insects and disease. So it's basically a chemical system, and it's a monocrop system. So, nature doesn't work that way. Nature has diversity. And also for most, like 98% of farmers, they plant one crop, and then the rest of the year, the soil is just fallow. There's nothing growing in it. And that definitely is not a natural phenomenon. So what I feel one of the most critical things to do is to move animals back out on pasture, to convert these corn and soybean properties to pasture, plant perennial grasses, and then put animals back out on the pasture. This is the way, basically, excuse me. I'm sorry. Grasses co-evolved with animals, and that whole symbiosis between grazing animals and predators and cows and mycorrhizal fungi in the soil created, in many areas in the Midwest, deep humus soils that are 3, 4, 5, 6, 8 feet deep. Just an enormous store of minerals and nutrients to grow plants with, and that has largely been destroyed with monocrop agriculture over the last few years. So the key is to what we do is we restore the minerals, a kind of a kickstart organic matter, and we restore thousands of species of microbes, and then we plant perennial grasses, and then bring grazing animals in. But the critical thing with grazing animals is that they need to be grazed in such a way that they're eating the grasses when they're mature, but they're not eaten down too close to the ground, because when that happens, a great amount of the roots die back, and it really slows down the grass growth. So the grazing is crucial. The animals really need to be moved regularly so that the grass is eaten at the right time. And also the way that animals were grazed in nature, there were predators constantly ready to attack the cows or any grazing animals, so that they moved on. They ate the grass. They weren't picky about what they ate everything, and they moved on, leaving grass 6 or 8 inches long to readily grow back again. And then whether it's buffalo or deer, or reindeer, depending on where they are in the world, they cycle back around when the grass is mature, has regrown. So this puts an enormous amount of roots, organic matter, root exudates, which is basically just what it sounds, nutrients that are exuded from the roots to feed soil microbes. It ends up pumping an enormous amount of carbon into the soil, which gets sequestered, which improves soil physical properties, supports the microbes in the soil, and just generally increases the productivity of the whole agricultural system. So what our system does is, as closely as possible, restores that type of, we bring back minerals so that we end up starting off with a high degree of productivity, high degree of nutrient density for the animals. The research project we did this year, we literally doubled the rate of weight gain of animals, from about 1.5 pounds a day to 3 pounds a day. So economically for farmers, it's much more sustainable. We're growing far more forage per acre so that we can produce much more food on less acreage. I think you mentioned climate, how this affects climate is, as many of you probably know, you have millions and millions of acres of old growth tropical forests being cut down in the Amazon and Indonesia and all over the world to grow corn and soybeans or to graze farm animals. And these practices, just like they did in the United States and pretty much the rest of the world, is these practices oxidize soil carbon. And when that happens, the minerals that are stored in that organic matter wash away. There's no longer a home for the microbes in the soil. They put poisons on, the poisons kill microbes. The whole system is you start with a tropical rainforest and you end up with a desert. And that's just been happening for at least hundreds of years, if not thousands of years of human history, right from the beginning of agriculture. So that's really what we need to go back to, looking at an animal-based system. We need to go back to what nature, when Europeans arrived to North America, there were something like 60 million buffalo being supported on the plains, on these, diverse grasses with rich soils in North America. And so basically we need to restore that method. And so the one intersection with the climate is that by growing more food on less land, and by having a farming system that actually regenerates soil, that actually makes soil better every year, then we can stop cutting down rainforests, which are crucial for cooling the planet, for providing oxygen, for providing rainfall. So, this kind of system also sequesters atmospheric carbon, so that we lower atmospheric carbon, take that carbon, put it in the soil where it actually does us some good, and allows us to actually have land that we can reforest, because forests are the best way to actually cool the planet. So by having a food system that can produce food on less acreage, we have more land to replant back into forest. And that's kind of the other half of what I've been doing is it turns out that much of the land that reforestation is happening on in many parts of the world, the soil is so depleted that the trees die, or they grow very slowly. So what I found is that when I do the same thing before planting trees as we do for growing food, is the trees grow much faster. We can support many more trees per acre, so that we can sequester more carbon and grow the trees fast, create a forest faster and healthier and more sustainably, and the trees will live for a long time. Currently in many of our forests, the trees get infected by insects and disease, and the trees are dying in 30, 40, 50 years instead of 300, 400, 500 years, which is what many trees are supposed to survive. Is you go into an old forest with 3 foot, 4 foot, 6 foot diameter trees, you just don't see that in second growth forests anymore. So we believe that by restoring the nutrient density of the soil when we go to plant trees, that we can have those kind of forests again and cool the planet.
Yeah, there are so many wonderful things you mentioned in that explanation. So thank you for sharing that. One of the things I was thinking about as you were talking is just there seems to be this theme of abundance, right? So there's especially when I was thinking about your farming system, there's abundance in terms of production, right? So there's more being produced, and at the same time, there's also more abundance in terms of nutrient density, both for maybe livestock and then also for humans consuming food, things like that. And then as a result of all of that, there's more abundance in terms of the economy. So there's a better economic side for farmers. And then on top of all of that, there's abundance in terms of the biodiversity and in terms of the ecosystem. There's just abundance in terms of a much healthier system right there. And I kind of want to turn to that point of biodiversity, right? And you were touching upon, kind of how a healthy, functioning biodiverse ecosystems, you were also talking about when you're talking about your forestry system, is beneficial for climate, and that implementing more restorative, regenerative, organic practices are super beneficial for climate. So I want to ask you a question about there's at least something I've been exposed to lately. I'm also a student at the Massachusetts College of Liberal Arts, and we recently had a film screening of a film called Open Sesame last semester, which talked about seed saving and talked about the importance of heirloom seeds and preserving seed diversity, and how important that is, not just for the nutrient density that we consume, the health of soil, but also for humans and communities. So could you explain a little bit about what heirloom seeds are and why they're important?
I think that the term is an apt one, because historically, before you had seed companies, families would pass down seeds from one generation to another. If they had a farm, then people saved their own seed and they used that for planting the next year. So I think it's an absolutely crucial practice. you have some of the big seed companies that are purchasing national seed depositories so that they get all this genetic material and basically keep it for themselves. And I think that that's really a horrible practice. You know, humans need the ability to grow food themselves. You mentioned food nutrient density. I saw one study that was done, I think, in 1948, where they had, just begun doing a lot of breeding with corn and developed hybrid varieties that where the farmers couldn't take the seeds and replant them and get the same plant. They deliberately make the plant so that it does not produce the same variety the next time. It produces just something undependable. And so this farmer planted some of his family's heirloom seed, corn from historically, and then he planted some of the new hybrid varieties. And and then he tested them for nutritional value, and the hybrid corn had something like some amounts of 16 different mineral nutrients, whereas the heirloom planted in the exact same soil at the same time in the same climate had 24 minerals in it. So even though the minerals were clearly in his soil, that hybrid corn that had been, in many cases, it's literally bred to not need minerals, because the seed companies know that soils are becoming depleted. So they literally need to breed the plants so that they no longer need to use minerals that they used to use in the past. And I can give one example that one of my teachers told to me, which I found just so symptomatic of why our food has so little nutrition in it, is he explained what happened around the turn of the 20th century. In other words, in the early 1900s, the farmers were already beginning to breed their crops. And what was happening was that wheat out in the Midwest was blowing down in the wind. It was 6-8 feet tall, but it used to just wave in the wind. But all of a sudden it started laying down so that the farmers couldn't harvest their wheat anymore. So they finally discovered what the problem was. And the problem is that year after year after year, farmers were depleting the silica in soil. And silica is crucial for the structural integrity of plants. It's also actually critical for the structural integrity of every cell in our body. And it's one of the reasons that people have so many strokes, is because the integrity of our blood vessels isn't what it's supposed to be, because we're not getting the silica that we need. And so we have strokes. But in the case of these wheat plants, they were blowing down. So to me, the logical thing would have been, well, how do we put more silica back in the soil? Because we're obviously depleting it and the plants need it. But that's not what they did. What they did, and I'll give you one guess about what they did. They bred shorter plants that didn't catch the wind. And so they stopped having a problem. But then years went by, and even plants that had been bred shorter, even they started blowing down, because there was even less silica in, and there wasn't even enough to support the structural integrity of those plants. So they bred them and made them even shorter. So basically, farmers do not, they don't amend their soil with silica, unless you're a rice farmer, which it's crucial because there's so much rice and rice hull, so much silica in rice hulls. But that's the approach that the seed industry uses, is they will breed plants so that they no longer need nutrients that they evolved needing and that we need for our nutrition. And so partly what's happened, the fundamental thing that's happened is that the minerals have been sort of mined out of the soil with crop growing year after year. But then the whole system has kind of been locked in because the commercial seed varieties have been bred so that the plants can thrive in that nutrient poor environment. So the heirloom seeds, that's not the case. The heirloom seeds, when they have access to nutrient dense soil, they will absorb those nutrients and therefore continue to have the capability of producing more nutrient dense food if the nutrients are there.
That is absolutely fascinating. And also it's so interesting that, when you're talking about the wheat, it was so interesting to hear that instead of putting more silica into the soil, the solution was just to breed smaller plant species, which is kind of just going backwards in terms of solutions and creating a longer term problem. So I think that's really interesting to learn about, but also really fascinating to learn about the importance of heirloom seeds and how they're so important for human health, for keeping that nutrient density, which is a recurring theme, and for keeping communities together. They're really important for both social and environmental reasons. So it's really wonderful to learn more about. So thank you for sharing that.
One thing I just might add to that is that that approach, rather than working with nature and saying how to accommodate nature, they're basically saying, how do we trick nature, or how do we circumvent nature? And basically that is, in my thinking, that is the history of agriculture. It's just, how can we circumvent nature rather than how can we? And I believe what we're showing now is that by working with nature and by restoring natural systems, as you mentioned, they're far more abundant and better for everyone. So.
Absolutely. Yeah, that's a fantastic point. Thank you. My last question for you is something you've already talked about a little bit, but I will ask it again just in case you'd like to add something. But what are the benefits of regenerative organic farming and gardening when it comes to stabilizing climate? Is there anything you'd like to add to that?
One thing is that we need to get back to perennial plants as much as possible. As I mentioned, so many millions of acres are growing annual corn and soybean crops, which are not, they are not regenerative. Even when they're done in a no-till way, they are not building soil. They are depleting soil. So with perennial grasses that don't have to be replanted, and to have them more and more diverse. I have read studies that showed that the tall grass prairies had as many as 700 species of different grasses and forbs and legumes, all growing together. So, if it's cold, there's certain plants. If it's hot, if it's dry, if it's sunny, if it's cloudy, you have plants that are thriving under those conditions, and all kind of supporting each other. So the more diversity there are, the more resilient the ecosystem is. But in the case of really cooling the planet, restoring soil so that trees thrive, and forests create clouds that reflect the sun back off the planet. They evaporate water. They remove heat from the planet very, very powerfully. So, and having food systems that are more productive so that we can actually restore forests is pretty crucial.
Yeah, thank you for sharing that, because those are all very important points, and also they serve as important reminders as well. So thank you for sharing that. And also thank you for taking the time to share all of this with us today and for answering these questions. This is very enlightening and super informative and fascinating. So thank you so much for your time. I am very grateful for you.
I'm delighted, and thank you for hosting this.